Hello everyone, this is mhjhamza, and in this video we'll continue from where we left off in the previous video. Just to give you a quick recap, in the previous video we downloaded our dataset. We also created a couple of directories and moved our images from one directory to another. Next we pre-processed the dataset, and for that we also installed pillow library, which was needed for creating the data generator. In this video, we'll be building the convolutional neural network from scratch. For that, the very first thing we'll be doing is importing the libraries that we'll be needing in this video. The first thing I'll be importing would be sequential model. It's the same model that we imported in the previous video from TensorFlow Keras models. Now I'll be needing your attention because we are going to import some things that we'll be using throughout the upcoming videos. The first thing we'll import is conv2D. This is the convolutional layer. Max pooling 2D. This will do the max pooling. Next is dense layer, flatten, and dropout. Before actually implementing the model, let's learn what a convolutional neural network is. A COVNet is a type of deep learning model universally used in computer vision applications. Importantly, a COVNet takes an input tensor of shape, image height, image width, and image channels, which would be 1 in our case. Okay, let's build the model. First, we'll create the model from our sequential class. Now is the best time to learn about convolution operation and max pooling operation. The fundamental difference between a convolutional layer and a dense layer is that dense layer learns the global patterns in their input feature space, whereas the convolution layer learns the local patterns in their input space. Image could be broken down into smaller pieces, and this could be lines, circles, edges, or texture from an image. Max pooling. Max pooling downsamples the feature maps. It reduces the resolution of an image without losing important features. For example, you can provide a 64 by 64 image, and max pooling can reduce it to 32 by 32. It moves a small box all over the image and selects the pixels with the highest value and continues striding. If we don't pool, the layers could have millions of unnecessary parameters. Now that we know what convolution and max pooling is, let's proceed. We have already defined our model, now we'll be adding layers to it. We'll call the add function and pass the conv2D. Convolution 2D requires a couple of parameters. The first one is number of neurons we want in that layer. The next one is the kernel size. In this case, it's 3 by 3. The next is activation. We discussed that in the last video. And the last one would be input shape. The input shape is 100 by 100 by 1 because we are dealing with grayscale images of size 100 by 100. The next layer we'll be adding is max pooling 2D, and in this case we'll just pass the kernel size, which is going to be 2 by 2. So after adding convolution and pooling layer, we'll be adding another convolution and pooling layer. This time we won't be passing any input shape. We'll do that again and one last time. So this over here is the convolution base. Right now we haven't added any densely connected layer. That we'll be doing in the next cell. Before we add a dense layer, we need to flatten our input. So first we'll add a flattening layer. The next layer is going to be dense. The dense layer has 512 neurons, and the activation function we are using is relu. Lastly, we'll have our last output layer. It's going to be a dense layer, and this would have only one neuron. This is because we are dealing with a binary problem, and one neuron is sufficient to tell us whether the class is 0 or 1. Also note that the last activation function is sigmoid and not relu. Now I'm going to show you how our model actually looks. So for that, I'll be calling the summary function on our model object. By calling the summary function on model object, you will get all the layers included in the model. This would contain the layer type, the output shape, and the parameters in that particular layer. Also observe that we added a conv2D layer first, followed by a max pooling. We did that a couple of times, so you can see a conv2D over here, followed by a max pooling again. Conv2D, max pooling, conv2D, max pooling. The last three layers are flatten, dense, and dense. And also note that the last output layer has only one neuron. The total parameters of our model are over 1 million. Now it's time to compile the model, and for compiling I'll be using a loss, which is going to be binary cross entropy, because we are dealing with a binary problem right now. This is the optimizer we want to use for our problem. The last one is the metric we are concerned about, and we are concerned about accuracy. Let's go ahead and compile this model. So that's all from this video. Today we learned about convolution layer, pooling layer. We also built our first ever convolutional neural network and compiled it. In the next videos, we'll be training our CNN model. So I'll see you next time. So people, that's about it from this video. I hope you enjoyed this video and I hope you learned something new. In case you liked the video, please give it a thumbs up. And in case you think that the video taught you something new, please share it with your juniors and your peers. Also, if you want to see more similar videos, please subscribe.